Hello everyone. Now we start the third type of inventory model. So the questions can be raised like that. Develop an EOQ model with constant demand and constant deterioration under shortage. Okay. So the first step is writing the assumptions. Okay. So first one, demand is constant. So demand rate is constant. Second is deterioration rate is constant. Third one, shortages is allowed. Fourth one, lead time is 0. Now we go for the second step which is notations. So first one, D denote the demand rate. Theta, this is denote the rate of deterioration. And its value is lies between 0 and 1. And the next one is IT. It represents the inventory level. At time T. Q represent the order quantity. Okay. B represent back order quantity. C1 represent ordering cost. C2 represent holding cost. Holding cost per unit time. C3 represent deterioration cost per unit time. CS represent shortage cost. Per unit. And T represent the cycle length. And there will be one more which is T1. This is the time at which shortage occur. Okay, so now we move to the third step, which is mathematical modeling. We all know this represent time and this represent inventory. Okay, since this is a order model, so we order Q quantity initially, and then our inventory is depleted due to the joint effect of demand and deterioration. At that time, T1 inventory becomes zero, means shortages arises. Okay, and this is the cycle time T. Now this is depleted due to the joint effect of demand and deterioration. Okay, so now we make differential equations from this graph. So the governing, we can write some theory here as we can write initially. Since this is a order model, so it may be for retailer, buyer, and supplier. So we can write any of these. So in the beginning, retailers order Q quantity from the supplier. Okay. So at time T1, the retailer inventory level is HQ. Okay. After that, in the time interval, 0 to T1, the inventory level become the inventory level deplete due to the joint effect of demand and deterioration. And at time T1, inventory level become 0. In the interval, in this time, shortage is start and shortages occur in the interval T1 to T. So the governing differential equation Describing the inventory level. Become DIT upon DT equals this is decrease due to demand and deterioration. So we can write minus T and minus theta IT. Okay. So it can be written as. And for this interval, this is for interval 0 to T1. And for this interval, it becomes the IT upon DT equals minus T. And this is for interval T1 to T. Okay. So we have two differential equations. First one is this d of it upon dt equals minus t minus theta it. This is first, and we can write it like that d of it upon dt plus theta it equals minus t. And this is in the interval 0 to t1. And second one is d of it upon dt equals minus t. And this is in the interval t1 to t. We can say this is equation first and this is equation second. Now from this figure, we see the boundary condition at time 0, the inventory is Q. At time t1, the inventory becomes 0, and at time t, we have inventory negative. And so we say this is back order quantity, which is B. Okay, so I'm writing the boundary condition here. So at t equals 0, I0 is Q. T equals T1, I of T1 is 0 and T of T, I of T is 0. Sorry, I of T is minus B. This is backorder one. Okay. This negative sign represents that we don't have inventory. Okay. Means we have a shortage of this amount. Okay. So first we solve these two equations. So from equation first, we can write it dit upon dt plus theta it equals minus t. Just apply. This is linear in it, so we can find integrating factor. So it will come e to the power theta t. So its solution will be it to the power theta t equals minus t e to the power theta t plus a constant c. Okay, so it can be written as it e to the power theta t equals minus t e to the power theta t upon theta plus a constant c. Okay, now we use the boundary condition to find this value of c. So at t equals to t1, I of t1 is 0. So this will become 0 and this will become minus d e to the power theta t1 upon d plus c. So value of c will be d to the power theta t1 upon theta. Okay, just put this value in this. So it will become it equals minus d upon theta e to the power theta t plus d e to the power theta t1 upon theta. So we can write it it equals d upon theta e to the power this is e to the power theta also. So when we divide it by e to the power theta, so it becomes e to the power theta t1 minus t and minus 1. So this is the inventory level in the interval 0 to t1. So this is the inventory level in the interval 0 to t1. Now we solve equation 2. So from equation 2, we can write it dit upon dt equal minus d. So on integrate we get it equals minus dt plus constant c dash. So we can find the value of this constant by using the boundary condition. So at t equals to t1 it becomes 0 and it is minus t of t1 plus c. So it becomes it equals d minus dt plus d t1. So it equals, we can take d as common. So t1 minus t. So this is the inventory level from t1 to t. Okay. Now from this we can say this is equation 3 and this is equation 4. Now to find order quantity, so order quantity will be order quantity is given by, just use this boundary condition. So put t equals to 0 in equation 3. So we get the order quantity. So this will become d upon theta e to the power theta t1 minus 1. And backorder quantity, just put t equals to t1, then we get order. So minus b equals d t1 minus capital T. So we can write it b equals d capital T minus t1. Now we go for next, which is inventory cost. So first cost is ordering cost. This is equal to C1, and holding cost. This is equal to C2, and from this we can see the inventory is held only in the interval 0 to T1. So this is goes to 0 to T1 IT DT. So it can be written as C2 0 to T1. Now put the value of IT here. So this is d upon theta e to the power theta T1 minus theta T1 minus. This is T1 minus T and dt. C2 d upon theta, and we can integrate it. No. It is d upon theta e to the power theta T1 minus T minus 1 dt. So we can integrate it. So we get minus of e to the power theta T1 minus T upon, this is not. Now we put the value of IT. Yes, it is, right? It is this. D upon theta, e to the power theta, t1 minus t minus 1 dt. So we can write c2 d upon theta. We can integrate it minus theta t1 minus t minus t and this upon theta. Now we put the limit. So we get c2 theta upon c2 t upon theta, and after taking limit we get, when we take t equals to t1, so it become e to the power 0 plus this become e to the power theta t1 and minus t1 minus 0, and if we take LCM then it will be multiplied with theta, means either we can write it like that, e to the power minus e to the power 0 plus e to the power theta t1 upon theta minus t1. So it becomes c2 d upon, when we take LCM then it will come theta square, and we can write it e to the power theta t1 minus theta t1 minus 1. So this is the holding cost. Now the duration cost. So it is C3 0 to T1 theta IT dt. So just multiply with theta with this. So we get the rotation cost. So it will come d C3 theta upon theta square e to the power theta T1 minus theta T1 minus 1. Now the next cost is shortage cost. So this is minus CS, and shortage is occur in the interval T1 to T and IT dt. So it can be written as minus CS T1 to T, and the value of IT is D T1 minus T. So now this can be written as T1 T minus T squared by 2, and limit goes to T1 to T. So when we put the limit CST, we get T1 T minus T square by 2 minus T1 square plus T1 square by 2. So when we solve it, then now we can arrange this negative sign. So we get CSD, and this goes upon 2, and this goes to T square minus 2 T1 T plus T1 square. Now the total cost will be the sum of all these costs, means holding cost, deterioration cost, and shortage cost. So total cost equals ordering cost plus holding cost plus deterioration cost plus shortage cost. So here ordering cost is C1, Holding cost is C2 d upon theta square e to the power theta T1 minus theta T1 minus 1. Deterioration cost is C3 d theta upon theta square e to the power theta T1 minus theta T1 minus 1. And shortage cost is Cs d upon 2 t square minus 2 T1 t plus T1 square. Now average total cost will be this is Tc. So we can write AT. This is equal C1 by T plus we can combine it. So it can be written as C2. This D is common. C2 plus C3 theta upon theta square T, and this is e to the power theta T1 minus theta T1 minus 1 plus Cs D upon 2. We can divide it by T. So it will come T minus 2 T1 plus T1 square by T. Now our aim is to minimize the total cost. So this is our cost function, and we know that if we use the maxima and minima in the function, here we see that this is the function of two variables, first with T1 and second one with capital T. Means in this we use the concept of maxima and minima in two variables. So the first we find d del ATC upon del T is partially differentiate with respect to T, and put equal to 0 also partially differentiate with respect to T1. Then we find the value of T and T1, and then so it become when we differentiate it with respect to T, so it become minus C1 upon T plus minus dc2 plus c3 theta on theta square t square, and this is e to the power theta t1 minus theta t1 minus 1 plus cs d upon 2, and it will come 1 minus this become 0 minus t1 square by t square equal 0. So when we solve it, now equating the coefficient of t square, so we get 1 upon t square c1 plus dc2 plus c3 theta upon theta square and e to the power theta t1 minus theta t1 minus 1 and plus cs d upon t d upon 2 t1 square, and this is equal to cs d upon 2. Now the value of t square will be 2 into c1 plus d c2 plus c3 theta e to the power theta t1 minus theta t1 minus 1 plus c3 d t1 squared by 2 and divided by cs d. So value of t will be square root of 2 into c1 plus d c2 plus c3 theta e to the power theta t1 minus theta t1 minus 1 plus c3, this is cs d t1 square by 2 upon cs d. So this is the value of t. And now we find the optimal value of t1. So just differentiate it with respect to t1. We have ATC equals C1 upon T. Here we can write C1 upon T plus C2 plus C3 theta on T theta square T and e to the power theta T1 minus theta T1 minus 1 plus CS D upon T, and this is 2T, and T square minus 2 T1 T minus T1 square. We have this. So now del ATC upon del T. So it becomes 0. It is C2 plus C3 theta upon theta square T, and this is e to the power theta T1 upon into theta minus theta minus 0 plus Cs d